Good evening, all. So today we are starting our lecture, which is a very major topic in sustainability, which is EPD, Environmental Product Declaration. I also recorded one lecture for this, but that was insufficient, I thought. So I have put more much data in this lecture for EPD. Uh, so before starting, we have outline which contains detailed information on EPD example for steel, and EPD comparison for steel and concrete. So this lecture is going to be a very beneficial lecture, especially for the sustainability professionals who are working or who are just entered in the field, in the area. Here we have EPD overview, that EPD is actually transparent environmental label for the materials. It is basically a document. Okay, it is also based on life cycle assessment (LCA). It is verified to ISO 14025 or EN 15804. An EPD does not claim a product is green, but it discloses quantified environmental impacts. Here we have information inside in an EPD, means what items are included inside the EPDR, or what does an EPD show. EPD shows a product and functional unit, means here we have a brief or detail about the product unit and functional units. Means what in EPD, it declared quantity of product being assessed. For example, if they assess, if the manufacturer, for example, if we have a steel example, so if they tested or investigated a 1 kilogram or a quantity of anything like concrete, if they assess or investigate 1 meter, concrete is meter cube, but for example, anything like concrete walls, they assess a piece of wall for 1 meter square or tile, so they will include EPD for that. Okay, so 1 meter square of tile or 1 kilogram of cement or 1 meter cube of concrete. When it used when products are compared by amount, not by performance. And on other side, we have functional unit, the measured performance of a product over a defined function and lifetime. For example, 1 meter square of flooring used for 50 years. When it used when comparing products that provide the same function. In short, if I summarize the discussion, the product unit and functional units are, product unit is how much product, means how much product, and functional unit is what services the product provides and how for how long. So this is we have a brief discussion on product unit and functional unit. The next is life cycle stages, which are raw materials. So the any material stage, this has four common stages for the any material, like raw materials, its manufacturing, transports, and its end of life. And final is disposal. And third one is impact indicators. What are they? Global warming potential, in CO2 equivalents, acidification, eutrophication, energy use, and water consumption. So here we have a golden sentence that an EPD does not claim a product is green. It just discloses quantified environmental impacts of any product like steel or concrete or any building material. Here we have EPD example for structural steel, or simply you can say steel. Real steel example is for typical industry, okay, for an EPD. For example, it has like four sections: product, standard, key results, and end of life. So the product is hot rolled structural steel with weight 1 ton. Standard used is EN15804 compliant. Key results from A1 to A3 stages. Now here we have a discussion. There is a new word, A1 to A3 stages. What are they? Here we have discussion that A1 to A3 stages refer to the product stage in a life cycle assessment. LCA is defined by EN15804. A1 stage is raw material supply, when extraction and processing of raw materials. The next stage is A2, which is transport, means transport of raw materials to the manufacturing plant. And A3 is manufacturing, which is production of the final product at the factory. In short, A1 to A3 is equal to cradle to grave impacts of the product before it leaves the factory, which is commonly reported in EPD and used in lead material assessments. So here we have key results that global warming potential is ranges from 1.5, 1.7 to 2.0 ton CO2 of equivalent per ton, because this assessment is done for the ton, as we mentioned earlier. And recycled content is 90 to 98%. Energy source used for manufacturing this steel is electric arc furnace, EFA, and end of life is highly recyclable, which is 100%. Steel performs well in lead due to high recycled content and recyclability. Now we have to assess that how steel EPD support the lead, means how it contributes in the lead score. So EPD in lead version 4.1 in material resource category. It contributes to material resources like building, product disclosure and optimization, which is BPDO for the EPDA. One product with an EPD is equal to one disclosure point. Encourage what it do? It encourages low carbon material selections and supports whole building LGA strategies. Now we have a key message for sustainability professionals that why EPD matters. Everybody can ask you that, okay, why you are too much interested in EPD? Because EPDs enable data-driven sustainability decisions. Means we can make decision on the basis of availability of EPD of any material like concrete, steel, cement, or anything. It also helps compare steel versus concrete versus aluminum. Means we can compare the materials. Also essential for LEED certification and carbon reduction. Here we have EPD materials are comparison using EPDA data. Here we in this, as I mentioned in my outline, that we have three parts. First one was the discussion or overview. Second one was for the steel, and third one is comparison of two materials. So we have tried to compare steel and concrete. So steel, steel, okay. It is recycled content 98%, recyclability 100% at end of life. GWP is A1 to A3. I already mentioned in the last slide is 1 point. These are the values for GWP is 1.7 to 2.0 ton CO2 of equivalent per ton. Manufacturing by electric arc furnace. EPD availability, yes, availability widely available, standardized. Lead advantage, it contributes in strong material resources, MR, disclosure and optimization support. Now we have second material, concrete, which is ready mixed concrete. It has recycled content of low limited SCMs like fly ash and slags. Recyclability, down recycled crushed as aggregate. GWP for this is 250 to 450 kilogram CO2 equivalent per meter cube, because concrete is measured in meter cube. Manufacturing impact is cement clinker is equal to major CO2 source, because we have studied in our early classes that CO2 is major contribution from the cement factories. And water use in concrete is very high. Lead advantage, it depends on the mix design and SCM percentage, that what class of concrete or which grade concrete, for example, C40, C20, or whatever concrete is used during the process. Here we have summarized the EPD comparison table, okay, for both materials, steel and concrete. On the left side we have steel, on right we have concrete. So all the table is same, just we have summarized for your simplification that recycling content, end of life, carbon impact, energy source, EPD availability, and lead value here for the steel and here for the concrete. And if you compare, we have much more advantage for the steel as compared to concrete. In terms of energy use, in terms of water use, in terms of its end life, its recycled content, and EPD availability, and also the contribution in lead. So we we finalize or summarize that steel has more advantages to concrete, also in lead, because lead prefer to recycling of materials. Now we have keynotes for the first slide. This slide summarize the comparison of the materials. Steel is circular material, and steel performs better in circularity and recyclability. Another side, concrete is cement-driven emission, and concrete's impact depends heavily on cement content. So the core sentence or golden sentence for this is steel scores high on circularity and transparency, while concrete performance depends heavily on how much cement is reduced. EPDs make this visible in lead. Here we have overall summary of the lecture, that EPDs enable fair data-based comparison for lead decisions, and EPD enable fair data-based selection for the materials. Also, EPD do not rank the materials. This should be kept in mind, that EPD don't rank materials, but they allow sustainability engineers or professionals to compare environmental impacts objects within the same life cycle boundaries. So this is all about lead. Thank you so much for watching. If you have any query, just you let me know in the comment box. Thanks for watching. So we will meet with another great lecture. Thanks for watching.